On this episode of 5 Minutes of Cloud, we're going to talk about computing in the cloud system space. When we talk about compute in cloud systems, we're really talking about the entities, the physical devices, the virtualized devices that enable the actual applications to run. And today there are a couple of different technologies that enable that. But before we get into that, we can actually think about how we got to this point. When we started out in the cloud space really being the internet and the web services within the internet, we started out with a physical machine. We bought a server, often a Sun server at that point in time, or at some point some of the Intel servers were also being used. But basically a Sun machine that had a CPU, had memory, had some internal disk, and was running software to provide a web server. Initially, that was a one-to-one mapping. So a website would have a single server, and that was the world as we knew it. Some people realized that a single Sun server could actually support lots of websites because not every site was being hit very hard. And so in those environments, there was this concept of a virtual website, where you would basically take one server running one version of Apache or one Apache instance, and it would present lots of different website names all off of that one box. That same concept is sort of the predecessor of what we have today. And along the way to getting to our current model for compute in cloud, one of the things that happened was the enterprises also were looking at their environments and trying to figure out how they could also take this same kind of a concept of virtualized resource and apply it to their compute instances. In that case, they were looking at Intel-based x86 servers for the most part, and those servers had the problem that you would also have one application per server. But in that case, the application was tied more closely to the operating system, so it wasn't quite as easy to just say, well, I'll take that one application and pretend that I have 5 servers. Instead, this concept of virtualized servers came along, where people would run a special operating system, something like a VMware ESX or a Red Hat or Linux-based KVM environment. And those components, the hypervisor component, would virtualize the physical resource. So now my physical server looks like lots of little virtual servers. Well, they're not virtual from the perspective of the application, but they are virtualized servers within that space. In each one of those virtual servers, I would then run my own operating system. On top of that operating system, I could layer my application. And so the application thinks it has its own physical server, which is what it was expecting. This works out really well. It turns out that works really well in the cloud space as well. Elastic OnDemand resource is easier to provide if I have a pool of virtual servers rather than one single physical server or lots of physical servers to manipulate and manage. So we have our bare metal servers, we have now our virtual servers, and actually in almost a retrograde way of dealing with things, people have started to realize that for some services, it's okay to go back to that virtual web server model, where you have one application environment, one operating system, presenting lots of different resources on top of that. But the security in that early model really wasn't up to snuff for enterprise applications or even most web scale applications today. And the big shift there is this concept of a container, where we have one operating system, potentially a virtual operating system for all we care. It doesn't really matter to us, or a bare metal server providing an operating system. And on top of that, I layer a management software called a container engine. The container engine is just a process security boundary manager. And so I can run 10 web servers, all of them providing different websites, all on the same underlying operating system, and I can scale that system potentially much more efficiently because I don't have to replicate the entire operating system every time I want to create another virtual instance of my application or a bunch of different applications all on that one operating system. So that's the container space. So we now have bare metal, virtual bare metal, and containerized applications, and that makes up the space of compute today for the most part in the application and cloud scale services space. Now that's great, but there is still one issue that still has to be addressed in that. In order to manage all of that compute, where I might have had 100 physical servers, now I have 1,000 virtual servers and potentially tens of thousands of containers running on top of those sorts of environments. I need additional management tools. And in that that sense, now there are tools, both public provider-based tools, so an Amazon or a Microsoft Azure or Google Compute Engine can provide from bare metal in some cases all the way through virtual to container-based services, or I can do this in a private sense using a private cloud technology, something like OpenStack, to again provide bare metal, virtualized, or container-based resources and management. So that then sort of completes the picture. I have a way of managing all of these distributed containers in my cloud model, that on-demand self-service capabilities model. It's network attached, so it's a part of the cloud, and I can do compute, again, bare metal, virtual, or container-based compute, and use that in a number of different senses, from a service provider offered solution to a private-based solution using something like OpenStack. Thanks for watching. If you haven't already, don't forget to subscribe to our YouTube channel. In addition, if you want to stay apprised of the latest ongoing updates in the cloud space, sign up for our Twitter feed and our mailing list. We also update you on upcoming webinars and classes that we provide.